Yes. So what I was telling, that questions are basically very basic things. So if you want me to go slowly over the question,
Actually,
in that case, how we can complete the syllabus? Now,
your
for
sound is not clear, sir.
sound is not clear, in that case, you should tell me during the starting of the class. Not now. I finished the class. Now you are telling me that my sound is not clear. So how I can?
No, no, now I'm just not. I'm not talking. Now I'm just saying sound is not clear now.
And another thing for the super elevation portion, whatever we have studied right now, basically that concept was there in your school standard, maybe 9, 10 or 11, 12 maybe. So basically there are some advanced portion in the transportation over here. So basically for that reason, because for some portion I want to go very first, because otherwise I cannot complete the major portion like design of your pavilions and other things. Okay, so that's why basically I have.
Sound is breaking, sir. Your sound is now breaking.
Now is it clear? Is it clear right now?
Yes, sir. Yes, it's now.
Okay, so basically that's why I have given you all the notes before starting of the classes, because the syllabus of this subject is huge. Okay, that syllabus is huge. So for that reason, I have given you the notes so that you can have some idea or can go through the notes before the starting of the class. And another thing, suppose that numerical portions or that the derivation portion. So in the derivation portion, if you feel the difficulties, just tell me in that time, okay? So that I can manage according to your needs. And for the numericals of your first sessional, that is stopping side distance and overtaking side distance, basically in the overtaking side distance, what was given in that question, that you have to calculate what is the spacing of the vehicles, and all these data are given. So from the derivation itself, you know that there are some equation. Okay, so for the spacing, that equation is 0.7 pb plus 6. So you just have to calculate what is the speed in meter per second and put that in the formula and find out the speed. So is there any difficulties in this, or is there anything technical in that numerical? Nothing is there. You simply have to put the values of that problem in that equation, whatever is given, and you will get the result. So basically that is the thing. So if you are expecting that this type of easy things could be taught in your fifth semester class, in that case, that is a high expectation. I should tell that is a high expectation because I am
Actually, sir,
basically see I am also expecting something from you. That is, you are already familiar with all the basic questions and you are understanding whatever I am telling. So that's why you didn't raise any questions in that lectures. So from now on, whatever I am discussing in each and every class, if you face any difficulties, please just discuss the things. Because without the discussion, you cannot have a clear idea about what are the things which are happening. Okay, so in that case, you will be clear from your side, and I will be also satisfied that okay, you are understanding the things. So in my previous classes, what I observed that maximum of you, maximum not maximum, all of you are just listening or may not be listening.
actually, sir, sir, some basics things said that it is some basic terms and all. That some terms is okay, but sometimes it's new for us now since we are new, and then we are not come. Some students are pressure, regular student, not a diploma. So some there is just some term which we do
Okay,
not understand that terms,
yes,
no?
if the terms are
And
not
then
understand to you, in that case, you should tell me, na sir, this is not clear to me. Please discuss it again.
yes, yes, yes. But little bit, we feel it's little bit speed for us,
Speed for
because we need some time to observe,
okay.
understand,
Okay. So in
yeah.
that case, okay, I'll go
And then
slowly for that for the thing. For the derivation portion, it is okay
yes,
now. For the theoretical portion, I think you can cover from the.
yeah, yeah. Theoretical to it's fine, and derivation, numerical should be a little bit,
Okay.
details.
Another thing for the numerical you can do because see in the online classes that covering that numerical portion is little bit difficult. Okay, so I will try to help you in that factor. So what you can do, suppose today I have discussed about the super elevation. Okay, so after the class I'll give you some numerical problem. Okay, so in the numerical I will try to discuss with you how to solve this that numerical, and you in your home you just try with pen and paper to solve that problem. In that case, I think that would be clear. In that case, if you feel any difficulties, in that case, we can discuss with me. I think that would be okay.
So the problem is only this numerical derivation and the important topic like super elevations, and this
Okay.
topic should be elaborate more. That's it only.
Okay. So basically, the
So,
thing is that whatever chapter we are discussing, the geometry design. Okay. So we are now basically discussing the geometry design. So basically, uh, that particular chapter is very much brief in the transportation engineering because the geometric design that itself is a subject in your next semester. Are you getting me? So
yes,
basically, in that portion, in the transportation engineering, that is the overall subject. So in the transportation engineering, that overall subject, geometric design, that is a small portion. Okay, that is a small portion, and that is very much brief in nature as per your syllabus. That is very much brief because there is a special subject in your sixth semester which will only consider about the geometric design. So in that case, their knowledge would be elaborate, very elaborate. There would be one chapter with 5 units, and that will be considering only the geometric features. So basically, that is the reason I'm going very first. And another thing, your total allotted classes is 20 classes for that particular chapter. So within that 20 classes, I have to complete the total syllabus. Now we are only trying to go for the unit 2, and unit 2 is not over. Okay, there are unit 3. Unit 3 is lengthy. Unit 4 is very important. Then unit 5 is basically your some theoretical portion is there. And that portion, that is unit 5, that is design of that pavement material, pavement. So for that, you have to complete this in this semester only, because there is no special subject mentioning that design of that pavement structures or design of that pavement, design of that bituminous pavement, design of that rigid pavement. Basically, that is the thing. So the thing is, okay, I'll go slow about the derivation portion. And another
If you
thing,
can, sir, derivation and this numerical, you make it, notes in simple way and send it in the group if you can. Some questions,
okay, so
some derivation.
see, the notes and derivations are already there in your lectures, whatever lecture note I have shared, and believe me, that is the most easiest way to elaborate all these things. And another thing, for the derivation portion, for your semester, you just need only the final equation. You just remember it. Okay, you just need only the final equation. The derivation portion is basically not in your syllabus. The derivation portion basically I have included to make you understand about that equation. But for your semester, only the final equation is required. So suppose for the super elevation, uh, only this only this portion is required for you. U plus F equal to B square by G. Okay, basically that is only in your syllabus. Nothing is there. So basically, that derivation portion, I have write it down most easiest way. You cannot find any easier way than this to make you understand about that what is happening over there. But your main equation is this one. So basically, in your semester, you just have to talk about that final equation, that is E plus F equal to B squared by GR, and applying this, you have to just solve some simple numericals. Simple numerical means, suppose your value of E is given, your value of B is given, and R is given, you have to find out what is the value of F, like that. So your numerical portion would be like that. Suppose your E is, F is given, P is given, and R is given, what is the value of E? Are you getting me?
Okay, okay, sir.
So basically, that's why I'm going first, because that portion is not in your syllabus. Well, let me start the next chapter. In that case, first we will discuss about one numerical. Okay, for the previous case, we have already discussed about the super elevation design. So your super elevation design formula was E plus F equal to V square divided by GR. Okay, E plus F equal to V square by GR. Now, let me discuss one particular thing which is very much unique to our country. So basically, in foreign country, what happens? Basically, there are little variation in the type of the traffic which is moving over a road. Okay, suppose there are only cars. If there is truck, there is separate lane for the trucks. Something like that. All these things are organized. But in our condition, in Indian condition, what happens? In a particular same place or in a particular same road stretch, all the different types of vehicles are moving. Okay. So basically, if one particular stretch of the road is there, you can observe buses are moving over there, cars are moving over there, auto rickshaws are moving over there. In some cases, bullock cars are moving over there. Your horse-drawn cars are moving over there. So basically, in such situation, it is difficult to estimate what would be the superdeviation. Now, why it is difficult? Because see, the speed of different type of vehicles are different. You cannot compare the speed of a car with the speed of a bullock car. You cannot compare the speed of a car to the speed of a auto rickshaw. Okay, so in that case, if you go for the design speed as per the documentation provided over there, in such cases, what will happen? Suppose you are designing with a design speed of 80 kilometer per hour. Okay, so in such cases, a auto rickshaw cannot go up to 80 kilometer per hour. Okay, its maximum speed may be 40 kilometer per hour. So if you design your super elevation keeping in view of the 80 kilometer per hour, in such cases, what will happen? There will be very much rise of that outer edge of the pavement with respect to the inner edge, with respect to the auto rickshaw. So in such cases, there will be chances that that auto rickshaw cannot move over that particular portion, move over that particular horizontal path. Okay, so basically what I'm trying to say is if your speed is more, your super elevation would also be more because your super elevation equation is E plus F equal to E squared by GR. So as your speed increases, your super elevation increases. So for the 80 kilometer per hour, your super elevation may be this one, but for the 40 kilometer per hour, your super elevation will be lower. So if a vehicle, suppose a vehicle with 40 kilometer per hour speed is moving over a particular road which have a super elevation which is designed based on the 80 kilometer per hour speed, in such cases what will happen? The vehicle will be moving or skidding in that inner direction, or the vehicle may overturn in the inner direction because of the high rise of the outward portion. Okay, so in such cases, what will happen? Accident may happen. So therefore, for the mixed traffic conditions, there are some requirements or there are some steps following which you will have to design your super elevation. So what are these steps? So there are four steps. So first step is you have to design the super elevation considering the 75% of the design speed and neglecting the friction. Now, how it will happen? So your equation was E plus F equal to V square by GR. So you are neglecting friction, that is F value is 0, and you are considering V as 75% of the, that is 0.75. Okay, so with this, you are calculating what is the super elevation, that is E. Okay, and this equation is for the V which is in kilometer per hour. So you are calculating your super elevation, neglecting the friction, and considering your 75% of the design speed. Now, step number two is checking whether the super elevation is within the limit or not. So as per the IRC recommendation, your super elevation limit is maximum limit is 7% or 0.007. Okay, so from the first equation, if you are getting a super elevation value of more than 0.07, in that case you have to consider the maximum super elevation of 0.07. Okay. Now, if in the first equation you are getting a super elevation value lower than the 0.07, in that case it is okay. Your design is finished. Okay. You have completed the design. So suppose you are getting from the using equation one, you are getting a super elevation value of 0.05. In that case, whatever value you are getting, that value is your design super elevation, and you can directly go for the design of that super elevation portion. Okay. But if you are getting, suppose you are getting a super elevation value of 0.09, in such cases, what you have to adopt? You have to adopt a super elevation value of 0.07 to proceed with the next step. Now, what is the next step? In the next step, you will provide a super elevation value of 0.07. You will provide a full speed, full design speed, and you have to find out what is the coefficient of the friction value. So your E plus F equal to square divided by GR. Okay, so you know now your E value is 0.07. Now considering E value is 0.07, you have to calculate what is the value of F. So your value of F would be V square by GR minus 0.07. Now what is the next step? Next is now you have to check whether your coefficient of friction value, that is F value, that maximum value of the coefficient of friction, lateral friction is 0.15. So considering this lateral friction value F is 0.15, you have to find out whether your calculated value of F is more than or lesser than 0.15. Now, if it is lesser than 0.15, suppose you are getting a coefficient of friction value of 0.14, in that case, whatever super elevation, that is 7% super elevation, they provided, that super elevation is complete. Okay. Now, if you are getting a coefficient of friction value of more than 0.15, suppose 0.17 or 0.20, in such cases, what you have to do? In such cases, you have to consider that maximum coefficient of lateral friction value as 0.15, and you have to find out what is the value of speed. So how you will calculate this? Your E plus F equal to square divided by GR. Now your value of E is 0.07 and your value of F is 0.15. So considering this both these value, you know what is the value of G and you know what is the value of R, because radius of curvature is required whenever you are calculating the super elevation, and you can easily estimate the radius of the curvature value from the field. So from that you have to find out what is the value of G. Okay. Now, if the calculated value of V is lesser than your design speed, in that case, your super elevation, whatever maximum super elevation you are providing, that is okay. Now, if your design speed is lesser, if your calculated V is lesser than your design speed, if it is more than design speed, in that case it is okay. If it is lesser than your design speed, in such cases, what it will indicate? It will indicate that the maximum super elevation, whatever you are trying to provide over the stretch of the road, that is not enough for a design speed of suppose 80 kilometers per hour. Okay, so in such cases, you have to provide the speed restriction over that horizontal curve. So for that reason, in some of the horizontal curve, you might have seen that here speed restriction uh, uh, notices or some speed restriction posts are there. So it would be written like that, not more than 40 kilometer per hour speed, or not more than 50 kilometer per hour speed. So basically that is the reason why speed restriction is there in the horizontal car portion. Because with the design speed, that vehicle cannot overcome that horizontal car, because maximum super elevation is limited to at some extent. So these are the four steps to calculate the super elevation in the case of your mixed traffic condition. So I'll discuss this. Suppose one numerical is there. The design speed of a highway is 80 km per hour. There is a horizontal curve of radius 200 meter on a certain locality. Calculate the super elevation needed to maintain the speed if the maximum superelevation of 0.07 is not to be exceeded, calculate the maximum allowable speed on this horizontal curve. So in this equation, your maximum speed is given as 80 kilometer per hour. So basically, you have to design this for a mixed traffic condition. So in the mixed traffic condition, basically, if you have to calculate the super elevation for the mixed traffic condition, in such cases, in the question, it would be mentioned like that. So here design speed is 80 kilometer per hour. So first thing is, if you remember all this equation for the meter per second, in such cases you will to convert that 80 kilometer per hour into meter per second. So how you will convert? It would be like that: 80 into 1000 divided by 3600. So you will get that 80 kilometer per hour into meter per second. Now, there is a horizontal curve of radius 200 meters. So, radius R is given as 200 meter. G is your 9.81 meter per second square. And your coefficient of the lateral friction is 0.15. You just have to remember this. Okay. Your coefficient of lateral friction is 0.15 and coefficient of the longitudinal friction is 0.35 to 0.40 depending on the speed. Okay, then you have to calculate the super elevation. So how do you calculate? So first step is you have to calculate the super elevation, neglecting the friction and assuming the 75% of the design speed. So your E equal to 0.75 V square divided by GR. So you know the value of V, you know the value of G, you know the value of R, you have to calculate what is the value of E. So can you calculate this and tell me the value of E? Just calculate it and tell me the value of E. Just write the value in the chat. What is the value of E? If you calculate the E,
So, sir, we have to take the speed as a 2 kilometer per hour.
you just convert the
No,
speed into meter per second.
meter per second, na?
Yes, meter per second. So
Okay.
if you want to convert, in that case, 82,000 divided by 3600. So it will be meter per second.
By 36,000.
3600, 36, not 1000.
Oh.
Why 3600? See, if you multiply 80 into 1000, in that case, it will be in meter. Now it is basically it is given a kilometer per hour. Now we have to convert the hour into second. So from hour to minute, it is 60 into from 60 from minute to second, that is another 60. So 60 multiplied by 60 into 3600. Okay, so
Do we use value of f here, sir?
yes,
0. Where do we use the value of f? 0.15.
F now F is not required. For the first step only E is required. For the first step F would be 0, B plus F would be 0. Now if that value is not within 0.07, in that case you have to check for the F. For the first step, no F is required. So basically this is the first step. So for the first step, your equation would be E equal to 0.75 V whole square divided by GR. So did you get the value?
But I think it's not correct.
Uh, what value you are getting? Tell me.
It's like 5662 point something like that.
562. No. What is the calculated value of B you are getting?
There's 0.14.
Yes, it should be around 0.14. the value of c would be around 0.1. Your speed would be 22.22. You will get a speed value of 22.22 meter per second multiplied by 0.75 square.
That is 277.
Which one? 277?
The value of that
E. The value of E.
0.27 into 2.22 bracket square is equal to 277.
0.75 into 22.22.
Yes, square value is equal to 277.72.
Okay, divided by G into R.
Divided by 9.1 and it's come out like 5662.
No, divided by 9.81 into R. G into R. R is there now. R is
200.
200.
Yes.
So it will be 9.81
5 9 point.
into 200.
And can answer come out like 5662.
No, you have calculated wrongly. 0.75 into 22.22, you will get 16.665. So basically in the upper portion, let it be 16.66 square divided by GR. So 16.66 square, 16.66 into 16.66. The top portion would be 277.55.
1920.
270.55 divided by G is
277 को divide करता है
9.81 into R is
277
200.
divide.
So you will get a value of 0.14. So the value of Q would be 0.14.
Okay, it's coming.
Is coming now?
Yeah. Actually, I using scientific calculator, no, so I get confused.
Okay. So see here you are getting a value of E as 0.14. But what is the maximum limit of E? The maximum limit of E is 0.07. Okay, the maximum limit of E is 0.07. You cannot provide a super elevation more than 0.07. So in such cases, you have to go for the third step. What is the third step? Second step is checking. You have already checked and you have found that your calculated value of E is more than the limiting value. So you have to go for the third step. What is the third step? Your third step is E plus F equal to V square divided by GR. Here you have to consider the value of E as 0.07 and you have to find out the value of F. So your value of F would be, here the speed is full speed, that is 22.22 square divided by G into R minus 0.07. So calculate the value of F. Okay, the value of f would be around 0.11. Okay, the value of f would be around 0.11. So what does this indicate? It indicates that this value, calculated value of f is lower than that limiting value, that is 0.15. So in that case, you can say that whatever super elevation, that is 0.07, you have provided, that super elevation is safe for the design. So you can adopt the super elevation as 0.07. You don't have to go for the next step. Uh, Okay, that 0.11 is actually whoever is calculated 0.11, that you just recalculate it. It should be around 0.18. It should be around 0.18. Just check it. It would be like 22 point 22.22 square divided by 9.81 into 200 minus 0.07. Did you calculate this? Just calculate it. Please make it fast. Your lecture is about to end. Okay. Now this calculated value of f, that is you are getting 0.18, that value is more than your 0.15. So in that case, you have to go for the speed restriction. So how to calculate that speed restriction value? Your equation was E plus F equal to V square by GR. So you consider E as 0.07 and consider F as 0.15 V square by GR. Now you have to calculate what is the value of V. So whatever value of V you are getting, that value is basically your speed restriction value. I think you can calculate it. So let me finish this class over here. Okay, I am ending the class right now.
Thank you, sir.
0.15 is the coefficient of friction value. E plus F equal to V square by GR. Here F is the 0.15. That is the maximum value of F is 0.15.
Thank you, sir.
Mhm.